Hey everybody, this is Noah with Learn Meta Analysis, and I've gotten a good number of questions since we started this large language model course, or crash course if you will, on really important things like how do I know how big of a large language model I can actually run? And while I have some kind of really high level benchmarks, I find that these are not as helpful as actually seeing how something runs on your own machine. So I'm going to do a quick walkthrough of a couple different large language models, and we're going to look at the number of tokens per second that happen, and essentially how quickly it can answer our questions. So before we get into that, I think it's important to know what machine I am running this on. So as you can see, I'm running a PC right now. This is a 13th generation iCore i5 13600K. I have 32 gigs of memory installed, and my GPU is an NVIDIA GeForce RTX 4060, and importantly, this has 8 gigabytes of dedicated GPU memory, or VRAM. So let's go ahead and check out how to do this and what the speed is going to be. So as a little bit of a forewarning, I've done absolutely zero preparation for this other than thinking about, hey, that is a good idea that people mention that. We should do that. So I'm going to actually walk you through how to open WebUI because that's what we're going to use to test it. So if you followed our previous video, we used Docker to install WebUI. And what we can do is we just open Docker just like this, and this is what you're going to see. So when I open this up and I go to my containers, you can see that it says CPU usage none. That's because I don't actually have this running right now. So all I need to do to start WebUI is just click this start button here. That is going to initiate the container, and we'll see it up and running here in a moment. And then we will go ahead and launch this program. So I like to just give it a few seconds, and yeah, there we go. So you can see now it says the CPU percentage. I always wait for it to have that CPU percentage before I try opening it. So I'm gonna go ahead and try opening it now. And again, if you don't remember, we just click on the ports here to open it. Okay, and this is what opens up. So you can see I have a bunch of different models installed here. And what I would like to do is I think I want to go from some of the smallest models on my computer to the largest models on my computer so that you can get a good understanding of how quickly these go. And you can gain an understanding of how well they work. And again, my graphics card, I would say, is like I don't know, I bought it as a gaming graphics card, and it was like kind of a mid to low tier graphics card in the sense of I think it was about $400 to $500 at the time. And if you've looked into graphics card, you can spend so much money on graphics cards. It's crazy to me. But that said, it has 8 gigabytes of VRAM, and that's what I would really be paying attention to at this particular point for my understanding of large language models. So let's go ahead and start here with Llama 3.2, 1 billion parameters. So that's what we're going to do. We're going to use the same prompt every time. Let's say, can you tell me a funny story about a cow named, what's a good name for cow? Frankfurt. And I'm going to specify how long this story should be. Okay, and I'm going to copy that so that I can do it later. Okay, so you can see our 1 billion parameter model, super fast, right? I'm going to try not to actually read this story because then I'm going to start laughing, and you guys don't need to hear me laugh about a story that this came up with. But anyway, we're going to go down here and we're going to see the speed that this went at. So as we're looking at this information, whoops, there we go, we can see that the response tokens per second was 12.08. The prompt token was 178, and the total duration was 215. Actually, you know what? I feel like you guys are probably like me in that you like numbers. So let me open up Excel and let's actually just keep track of these, okay? And then that way we'll have a bit of a spreadsheet at the end. So we're going to have our model. We're going to have our response tokens per second and our prompt tokens per second. And then I'm going to have overall time. And I don't know if I'm going to be able to record this overall time really great, but I'm going to give it the old college try. Okay, so this was Llama 3.2 1B, response tokens per second. Let's go back here. Sorry, I'm trying to find my WebUI. Oh, really? I closed it? That was an amateur mistake, Noah. All right, let's try this again. Frankfurt, the lovable and mischievous cow. All right, let's see here. So response tokens, 11.51 and then 4100. So we'll say 11.51 and then 4100. And then overall time, where did this go here? Overall time, we had 261, and then there's a bunch of numbers, so I'm just gonna write, oh, approximate total. It's down there at the bottom, 2 seconds. So let's put that in our spreadsheet of 2 seconds. And I'm gonna put our prompt on here too. Okay, so now we have a benchmark for Llama 3.2, 1 billion parameters on an 8 gigabyte GPU. Now, let us switch to a different model. So that was our smallest at 1 billion. Let's see, I have a 2 billion parameter model here. I also have a 2.4. I'm just skimming through because I honestly can't remember all the different ones that I had. Let's do Exaone 3.5 because this is a relatively new one. And I'm gonna just put in the same prompt and we'll see what it comes up with. All right, Frankfurt was no ordinary bovine. Okay, I'm not gonna read that story because I'm gonna laugh. Okay, first I wanna write down Exaone 3.5. Where did my spreadsheet go? So Exaone 3.5, and this is a 2.4 billion parameter model, I think. Yeah, okay, so let's look at our speed here, 9.45 and 102, 9.45 and 102. I feel like there was a little more detail on that 102. I just want to write it down. 102.5 tokens per second. Okay, and our overall time here was what? 5 seconds. Okay, so you can already see how this is starting to slow down, right, as we get a little bit bigger model. Now, what's going to be really interesting is as we build this up. So we're at 2.4. Let's see, I don't want to go to 2.5. That's not a big enough step. Let's use phi3 here at 3.8 billion parameters and see what this says. Okay, so you can see this is taking a little bit longer, right? All right, wonderful. So I need to record this. Phi3, latest. And over here, when we get to tokens per second, we are at 6.99 and 433. 6.99 and 433. There was a decimal in there somewhere. 433.93, and then it was 11 seconds. All right, wonderful. Whoops, I put lastest. If you guys watch my other videos, you've seen I do a lot. I do that typo a lot. Or instead of latest, I put lastest. Anyway, so we had phi3. Phi3 is that's phi4. Okay, so phi3 was about 3.8 billion. Now let's jump up a little bit. We're gonna go to Mistral 7.2. So we're gonna just write that down so I don't forget. This will be Mistral latest, which is roughly 7.2 billion. Okay, now let's run this prompt and see what we come up with. All right, you can see it's a little bit slower still, but I think this is still perfectly acceptable. I would run this model at this speed. This isn't something that I find problematic in any way, shape, or form. Okay, so we have 4.57 as response tokens, so 4.57 and 174.85. 4.57, 174.85. Of course. Okay. And what was our overall time? I forgot to write that down. 13 seconds. Okay, so here you're starting to get a good map, right? So now let's get to a little bit bigger model. I'm gonna jump up a few billion parameters here, and we are going to go to Mistral-nemo, which is a 12 billion parameter model. So let me write that down, and we'll go ahead. Oh no, I lost my prompt. There we go. Okay, Mistral-nemo latest, and that is 12 billion. Mistral-nemo latest. Oh, look, I wrote lastest again. Okay, let's see what this came up with. Yeah, you can see it's still typing here. It's still, well, I shouldn't say typing. It's still generating here. I still think this is pretty good. Like, I think if I were actually working on something and I felt I needed a 12 billion parameter model, I would still use this. This is still acceptable to me. Like, I'm a very impatient person, but I feel like if I felt this was the correct model to be using, I could be patient while this generates its answer. But you can see I'm asking the same prompt. Again, this was 250 words, and it took considerably longer. So 1.38 response tokens and 1.38. And then let's jump back here and see what it says. 93, 71, and 38. 93.71 and 38 seconds. Okay, and now we're going to jump back into this again one last time here. So we were just working with a 12 billion parameter model. Now let's go to one. Oh, I don't even have it on my computer anymore. So I used to have a 32 billion parameter model on my computer. It was just too slow for me. So I think the largest that I have actually currently loaded is Qwen 2.5 14 billion, and you can see it's at almost 15 billion here. So let's do that and see what this comes up with. So I'm going to go ahead and enter this here. So we'll say Qwen 2.5, and this is the 14B version, and we're going to run this through with the same prompt one last time and see what we come up with. All right, you can see it is thinking. And it's still thinking. And it's still thinking. All right, here's our responses. So you can see once it does come up with its answer, it is a little bit quicker to actually generate than it was to, I like to say, think about it. I'm skimming through here, and it talks about found a shiny red superhero cape with Moo sphere emblazoned across it. So that's kind of funny. Okay, so once this finished generating here, we will write down the metrics and take a quick look at what that is for everything all together. And don't worry, I'm going to put these metrics into a Google Sheet, and I'll share this with you guys so that you can go look at the data yourself once this is all done. Now, I will say, like, I'm sure there's going to be some like LLM purists out there who are like, oh, that's not how you should test a model. You know, each one should have a new chat and yada, yada, yada. I'm sure that's probably the case. I'm sure this is not a real benchmark. This is not meant to be a real benchmark. This is meant to be like a normal person, not a computer scientist, sitting down at a computer, wants to use an LLM and can't figure out how big of an LLM they should use, or maybe they don't want to download 87 different models to figure out which one works well and which one doesn't from a speed perspective. This is purely what does it actually do, not looking for like overall optimized whatevers. So let's take a look here at its response. We have 0.75 response tokens. Okay. And now when we get to the prompt tokens, 57.88 and 1 minute and 4 seconds. 57.88 and 1 minute and 4 seconds. So we'll say 64 seconds just for simplicity. Okay, so hopefully, let me zoom in here. This will give you guys a little better view of our data that we're looking at. Let me right align these just so that it's not as much of a headache to look at. So as you can see, I have an 8 gigabyte graphics card. So I'm going to rate this here. This is an RTX GeForce 4060. Perfect. Okay, so as you can see, we have a very, very, very large discrepancy here between a 1 billion parameter model and a 14 billion parameter model. Basically, we go from nearly instant at 2 seconds response time all the way up to over a minute response time. I don't know about you guys, but I don't have the patience to wait a full minute. Wow, this sounds really petty when I say it out loud. I don't have the patience to wait a full minute to get a generated response. Like on my machine, usually when I'm asking questions and stuff, I want a pretty quick response. And so something else you need to keep in mind is not all these models are made to do the same thing. And by that, I mean they are trained on different data and they're good at different things. So So what I would encourage you to do is think about what models actually match your use case, and then also think about what size parameters will work on your machine. So unfortunately, I don't have a Mac handy to test these on a Mac, but I'm sure there are a bunch of benchmarking videos on YouTube on how to do that. But this will at least give you an idea from a PC perspective of how big of a graphics card can run how big of a model. I will say for my use cases, going up to about 12 billion parameters with Mistral-nemo, that's about the longest that I find my patients can wait to get an answer to something. Most of the time when I'm working on things, I want something a lot faster, so I'll use the smaller models even. And these are just a few that I grabbed, and like I said, they all have different use cases. So let's think about how we can actually pick what model we want to use. So what we're going to do is we're going to go to Ollama, and that's because I find it really easy to get models from Ollama into my actual Ollama software to be able to use it, and that's what I'm using with Open WebUI. So as we're scrolling through here, you can see there's some descriptions of what each model does, etc. But let's jump into let's jump into Llama 3.2 here. Llama is a pretty common model that a lot of people use, and so let's see what this says when we actually click on it. So there's a couple different things. The first thing I do is I skim through the README and see what it is that the model can do and what it's designed to do, and what they think it will work well for, right? So here they say it's text only, it's optimized for these different things. So that's the first thing that I look at, is what are they saying it is optimized for? And that's assuming that it's something that's going to meet my parameter needs, right? So the first thing I do is I look at the parameter needs. And if I'm scrolling through and I'm like Llama 3.3, I'm never gonna be able to run that on my machine, so I don't even bother trying, right? I don't even bother reading it. I look for things that I know I can actually run on my machine. Then when I open up the actual model page and I'm looking here, the next thing that I'll do is I'll look at the license agreement. And so you can click on the license and you can see if this is something that you actually want to use or not based on what's there. So this one, for example, has 2 different files about the license, but you can read all that. I trust that you will find the information there. So those are really the main things that I'm looking for when I'm looking for a model. First and foremost, I'm thinking about, will this model even run on my computer in a way that is acceptable to me? If yes, then I look at, is this model something that is actually going to be useful to me? So like, is it claimed to do the types of things well that I want this model to do? Yes or no? And so if it does both of those things, if it's designed to do what I want to do, and it has a parameter size that I know is going to run on my computer, then and only then do I usually go look at the license and see if it's something that I am agreeable with. And if so, then I will download the model and actually start testing it out. So that's the workflow that I use. I'm not saying it's necessarily the workflow that you should use, but that's the way that I have gotten into large language models and started exploring these things. And again, those of you who are like really knowledgeable about large language models are probably sitting there thinking like, oh, you can run a larger one if you use a certain quant, then it's going to run on your computer. Well, here's the thing, right? Like, for those of us just getting into large language models, we don't necessarily want to know about quants and how to modify these different things and how changing the quant of an LLM is actually going to change its responses and things like that. There are lots of different ways that you can manipulate how these things work, how well they work, what they work well for, how they respond, how well they run on different machines. Like, there's a million different things we can do to them. So this is really just meant to be a base level introduction to how to get some large language models running on your machine and the types of things that I like to look at when I'm choosing my large language model. Now, since we are on the model page, I'm realizing now that one of the things I did not mention before is this wonderful little drop-down menu. So as you look at the Ollama page, you will see that that 3.2 is marked for tools, 1 billion, and 3 billion. That's because they tagged it with the word tools, or it's in the category of tools, I should say. You can see it has 63 actual tags here. So if we click that, it lists all the different tags with quants and all sorts of those types of things. But if we look here, it says tools. That's what it's meant to do. It's meant to be a tool. And it's got 2 different parameter sizes that's available, 1 billion parameter and 3 billion parameter. So let me just go back here. There we go. So if I click here, I can choose if I want the 1 billion or the 3 billion. The one I showed you today was the 1 billion parameter model. And when I click that, you can see it just slightly changes the actual call that we would use to download and run this in Ollama. So if I switch it to 3 billion, you can see this changes to a 3 at the end in this case. So anyway, long story short, I hope this has been helpful for you. As we can see, I definitely prefer the smaller models. I find the smaller models really fun to work with. As you are working with them, you're probably, I'm guessing, depending upon what you're using it for, going to find it is quite different sometimes than what you're going to find from like a ChatGPT or Claude or Mistral or any of these other like leading big models that you use through a web interface. But the smaller models can be very good. It just depends on what your use case is and what that model was actually developed for. So I hope you guys have found this video helpful. If you do, please feel free to like and subscribe and leave a comment if you have any questions. I really like making videos that are helpful to you guys. So if you see something here and you're like, oh, how can I use this for this, or what do you know about this, or whatever, if things come to mind that might be helpful for you in academia land, working in academics, please let me know. And if I know enough about it, I will see if I can make a video about it and help you guys out. This is something I really like doing, and I'm having a lot of fun doing it, especially with large language models. They're kind of fun to play with. So anyway, that said, I'm going to stop rambling. Please feel free to like and subscribe. Leave a comment if you have any questions, and have a great afternoon, guys. And I will see you all in the next video. Thank you.